I don't know why I'm writing this like this, but whatever. This would be, the common denominator would be 1 minus sine theta, right? For some reason I'm writing it as two separate fractions.
Just extended the fraction.
I know, I don't really know what I'm doing, but I'm losing it. When I put that 1 minus sine theta up there, that negative is going to go to all of it, right? So just be really careful with that. So if I write 1 minus sine theta right now as two separate fractions, when I put that together, that's going to become minus 1 plus sine theta. If you forget to distribute that negative, then your proof's going to suck later on, right? Like, you're just going to be like, this is awful. Like, I can't do it because of a negative. Like, it just really stinks that you missed a proof because of the negative sign. And then my denominator is just 1 minus sine theta. Sometimes it's got to look worse before it gets better. So, you know, it's okay that it looks worse right now than when we started. If in about 5 or 6 steps it still looks way worse, then maybe we need to try something new. What do you think? What's next?
5 or 6 steps. That's a lot of steps.
Rewrite cotangent as cosine over sine?
Yes.
Yeah, I see nothing happening right now.
Cosine as.
I'm not going to rewrite cosine.
Rewrite sine.
So I'm going to change this to cosine over sine. Would have been super awesome if that had a cosine at the bottom and they canceled out, but it doesn't. That would have been an easy problem, right? That wouldn't have been a good day 2 problem. So now look on the top of that fraction again. We could say cosine times cosine is cosine squared. But other than that, we really got nothing still. But do we have now a fraction added to some other stuff that aren't fractions again? So now could I get a common denominator just among all these up here? Oh, that's exciting. Let's get a common denominator in the numerator. So cosine times cosine is cosine squared over, I'm going to put everything over sine. What would 1 be if I got a common denominator with sine? It's just going to be sine over sine, right? That's just going to become minus sine theta. And right now this is sine over 1, and I want it to be over sine, so what do I have to multiply at the top?
Square.
So sine times sine would be plus sine squared. But don't forget, that's just the numerator, all still over 1 minus sine theta. You can't be scared to use a little paper when you're doing this, right?
Yeah,
Don't try to squish that all in one line.
Step takes up 6 lines. Problem.
I thought you were going to say my life, so I'm okay. I can handle notebooks. But now that we found a common denominator twice, is there anything we could do?
Yeah, divide.
Cosine squared plus sine squared equals what? So I could write that as 1 minus sine theta over sine theta over 1 minus sine theta. Hey, it's looking better.
Now you can just do the reciprocal multiply.
When you have a fraction divided by something, you can change flip, multiply by the reciprocal. So we can say 1 minus sine theta over sine theta times 1 over 1 minus sine theta.
Uh-oh. Slice them on out there.
Do I need to write 1 over sine theta, or can I go ahead and just say that's cosecant?
Go ahead. Skip that.
We've done enough steps, right?
You can see it in kind of pain you go through it. You just need a nap like how we do that.
That's exciting, right? Persevere. That's the lesson of the day. Don't give up. What? I have not written on that in a while. It still says it's the 11th. The 12th. I had to call the doctor today for my son, and they're like, what's his birthday? And I'm like, 3/12/13. Today's his birthday. And then I almost cried.
You're like, today's his birthday, actually. That's what you said. I'm going to cry today, kids.
The lady just laughed on the phone when I told you guys I was gonna cry. Look at this one.
You told me happy birthday this morning.
I did, as he was crying as I left him, screaming, "Mommy, mommy!"
You should have stayed home with him on his birthday. That's probably his biggest win.
I told him I'm gonna bring some candles home. I made cupcakes for him to take.
I'm gonna bring you candles home.
I made cupcakes for him to take to daycare, and he can't even go to daycare to take his cupcakes because. So I told him I would bring candles home and we would blow candles today because we probably are gonna have to cancel his party on Saturday because we're all gonna have the stomach flu and we don't want to give that to the whole family. This is why I was rambling on my video because this is what happens when I wrote in my sub plans, please start the video at 1 minute 50 seconds.
She didn't. We just sat there and
Like, all you had to do was scroll. Like, you could have got out of your chair and scrolled up there.
It's
It was
like,
really funny.
I just don't know what to do. How do you stop it? How do you pause it? I just tried that. Like, hit the square button. Stop.
Square button.
She was.
Man, which side looks more fun to work with? They kind of really do, which means I don't think it matters. But if we choose this side and we want to turn it into this, what do you think would be a good first step?
Cotangent.
Change it to cotangents, right? Or if we choose to work with this side and change it to this, probably a good first step would be change all the cotangents to 1 over tangent. Some people would say, well, let's change the sine and cosine. And this is where you could, but usually changing the sines and cosines when you don't need to change the sines and cosines can turn into an uglier problem, and this is going to be ugly enough. So since it's about the same, I just chose to work with this side. So I'm going to go through and change every tangent to 1 over tangent. Keep track of your x's and y's. So I'm going to, not 1 over cotangent, right? Tangent is the same as 1 over cotangent x plus 1 over cotangent y over 1 minus, can I put all of this like this? 1 over cotangent x cotangent y. Is that okay?
I just erased the ones.
Can't do that. In my Math 137 class, on a quiz or a test, at one point, I forget what it was, like there was a 2 there that they wanted to get rid of, and so Daniel Seacrest just erased his 2 so that he had the right answer, and Jacob Berg drew a big picture of a tree right next to his 2 so that hopefully I would be distracted by the tree and not notice the 2 was there. It was pretty funny. It was wrong, but it was funny. I didn't.
Rogers gave me extra bonus because I just made a story for how I could sit on the phone.
That's ridiculous.
I'm not bending and can't bend that stuff. Not bending the license.
I think, again, the theme is just a bunch of common denominators. Can we get a common denominator up here and a common denominator down here? Yeah. So you just got to keep track of all your fractions. On the top, our common denominator would be cotangent x, cotangent y. So I just need to put this over here, so that would become cotangent y plus cotangent x. So that side needs a cotangent y, and this side needs a cotangent x. All over I know. Maybe we'll see that tomorrow.
I doubt it.
Why not?
That has nothing to do with pi.
Most of our songs don't have to do with pi.
Most of Miss Pi songs.
What does that mean? Oh, because I'm not
You're
going to be
here.
here.
Neither is Mr. Weiler.
I'm going to be here.
Why isn't Mr. Weiler gonna be here?
His girlfriend's grandma died.
Well, not even like in wedlock yet.
It's Beyonce now.
Fiance. They're getting married like this summer.
Well,
On June 20th.
Pretty much his wife.
humanity gets a priority straight.
Pretty much just what it was.
Unless something crazy happens.
Knock on this down.
Stop it. You just need to.
If something happened, you're gonna go.
I would. I just need this over here, right? So that's going to become cotangent x, cotangent y. I need nothing here, so that becomes minus 1. She teaches kindergarten. kindergarten.
What did you teach kindergarten? What subject?
Kindergarten. They don't alternate classrooms.
Okay, Karen. She's so a well-rounded educator.
She is. Unlike me, I just do math.
So you do large math.
2 plus 2 kind of easy.
Do you agree we pretty much have this here, right? What's the last step we could do? Flip and multiply, or if maybe just like the we've talked about the unit circle. If you have the same denominator in a complex fraction, when you keep change flip, that's always going to cancel out. Do you agree with that? So I'm okay however you want to do it. If you want to do the keep change flip and show it that way, if you just want to cross them out that way, I'm okay with that. That's why when we do like tangent and cotangent in the unit circle, that's why you can just cross the 2's out, because the complex fraction, it cancels out. So I'm just going to do this if you're okay with that. And I'm going to say that leaves cotangent y plus cotangent x. Do you like my cursive keys there? Over cotangent x, cotangent y minus 1. I think that's the right answer. That one wasn't so bad. I'm kind of very stressed about singing in Pi Day tomorrow.
I'm kind of excited that we're not actually doing anything in class.
I might want you to bring your homework to class tomorrow.
Actually,
So we can talk about homework questions.
Are we really going to have a homework quiz before my day? Here's the thing.
I didn't say homework quiz. I just want to go over homework questions.
So we're not
We
going
can do that Monday.
We can do that on Monday.
You don't make this decision.
Yes. I'm pretty sure we got numbers.
This is a dictatorship, not a democracy.
I like democracy.
Okay, this is homework 5-2, day 2. And I want to, I maybe, number 45 is interesting. Maybe number 45, at some point you end up with a sum or difference of cubes involving sine and cosine. And I thought maybe I should remind you of this lovely way to factor sum and difference of cubes on number 45. So it's good. On my homework, when I did it, like when I got to that part, I wrote, wow, in my notes, like in the margin. I was like, well, that's impressive. Who would have thought?
So that's number is 45?
Number 45.
I'll just raise that one.
So I want you to bring your homework tomorrow, because we have all class. You know, let's bring our homework so we can talk about the questions that you have. Okay? We'll see. Just bring your homework. We'll see how it goes.